Hello, class. Welcome to class. It's 1 o'clock. I see a question. Someone asked if we're having individual group consultations today. Uh, I think it's a good idea to have group consultations. I set up the email groups. I emailed each group to initiate group consultations by email. However, if you would like to have a consultation by phone, if you could do a group call, that's awesome. You could do that with me and get me to join a group call with you. You could tell me in advance, or you could just pull me into your group without advance planning. If I'm available, you can just ask me to join, and I might be able to because I'm often free. My schedule is quite flexible. Uh, so yeah, that's possible. I would like to consult with groups, especially before they collect data. Not as a requirement, but as assistance to you and your group, if that would be useful to you. All right. So yeah. Uh, all right. Well, maybe we should start with a 1 minute meditation now. If you don't mind, let's do that. If you just get in a comfortable place, position, close your eyes, and 1 minute starts now. I just started recording again. Thank you. I don't know how or why it stopped, but now I'm recording again. Thanks. All right. So when we do these reversals, where we go from A to B or B to A, that means from no treatment to treatment and then treatment back to no treatment. Each time we do this, we get more evidence in our observations to witness the presence or absence of an effect of the treatment. The reversal design provides high internal validity. It enables the demonstration of a dose-response relationship, or the dose and removal of dose response relationship. Multiple treatment reversal designs can be created, such as ABC, ACB. Notice the difference in the lettering. These are conditions. So there's condition A, B, C, A, C, B, where every condition is run twice. And because of the difference in order of the conditions, there is a counterbalancing of the order and the carryover effect. Now let's imagine that this is entirely within subjects. That's how we run single subject designs. We run it within subjects. So it's always the same person undergoing all conditions. And in this case, there are 6 conditions. Or you could say there's 3 conditions that are repeated in a different order. So condition A, the first one, then second is B, then C, then notice how A and B, sorry, it's A then B, and the next time it's A then C. First time it's B then C. Second time it's B then nothing at all. Then the first time there's C then A, and then there's C and then B. So there's a different condition order. If you look at every pair, every condition pair, every condition precedes and follows a different possible order of conditions. And that is to counterbalance, which means to balance or spread out evenly the effect of order. So if there was some special effect of condition B that influenced performance on condition C, we don't want to confound the effect of that order effect, meaning the effect of B on C. We don't want that to confound with our interpretation of the true effect of C. Because if we want to say there's an effect of C, we want to make sure that that effect of C is not due to the effect of B preceding C. So to do that, we have to balance out or spread out the effect of B on C by making sure that B on C doesn't happen repeatedly. So in the case of condition C, we see that B happened before C, and then when we test C again, A happened before C. So if there was some special effect of B on C, it would only be in half of the cases, half of the measurements of condition C. So that order effect is spread out. It's not entirely confounded with our measurement of any particular condition. Next slide, multiple baseline designs. Essentially, an A-B design, which we can call an interrupted time series design. I wrote that. I'm not entirely, let me think about that. Technically, it's not an interrupted time series design yet. Let me read on. Multiple measurements are taken before and after treatment. If we have multiple measurements taken before and after treatment, then it becomes an interrupted time series design. So let me clarify that here in the slides by a little editing, adjustment. If multiple measurements are taken before and after treatment, this becomes an interrupted time series design. The timing of treatment is staggered or spread out. Not every participant's treated the same, in the same order of conditions or the same timing of condition changes. And this helps to rule out historic effects, such as events in the news or events in people's personal lives that might correspond to each other. So if we stagger the treatment or stagger the changes or the condition orders or the event time of switching conditions, if we could stagger those across participants, then we can rule out history effects. Treatments can be within or between subjects. So you can treat people between participants, between behaviors, between settings. In other words, although single subject designs normally treat the same participant repeatedly, it's also possible to do this between subjects. Participant 1 could be tested with treatment or context or population 1 or A. And participant 2 could be treated with treatment 2 or context 2, population 2, etc. More variables may require more participants or more measurements of existing participants to rule out chance effects. However, each participant could be tested in treatments A, B, A, B, A, B, and in contexts A, B, A, B, A, B. So you could run multiple treatment conditions and multiple contexts, which means multiple variables or multiple kinds of variables, all at the same time. I'm adjusting the view so I can see more clearly here on the slide. Let's see. Each participant can be tested and let's see. Multiple treatment variables can be manipulated simultaneously and still establish effects due to treatment because of the treatment reversal design. All right, that's a really important point. Basically, the important thing here is the reversal design is so powerful. It has so much internal validity. And what that means is the treatment reversal design is so good and strong at providing evidence of causality. That's why we say it has very strong internal validity, because internal validity is the same as causality. They are the same evidence of causality. So if you want to know what is internal validity, it means the strength of evidence of causality. And when we use treatment reversal design, especially with a lot of reversals like AB, 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 that provides very strong internal validity or strong evidence of causality. And because because this method has such strong internal validity, we can even combine, we can even incorporate more variables, potentially many variables, if we're testing enough times, and if we want to do this with more participants. For example, let's say that A represents no therapy and B represents cognitive behavioral therapy. And we can do cognitive behavioral therapy, let's say once a week, and we test once a week. No, we can test every single day. All right, so we have daily testing and we have therapy once a week. On condition A, no therapy. Condition B is therapy. So we can test cognitive behavioral therapy on uh, on on smoking cessation. That means not smoking anymore. So in the control condition, a participant is measured every day and found to smoke an average of 7 cigarettes a day. Then in the therapy condition, they might smoke only 5 cigarettes a day. And then we could go back, to no treatment and measure, and maybe the smoking goes up to 7 cigarettes a day again. And we could do this with not only one participant, we could do this with another participant in another condition, another kind of condition. And that other condition could be not interested in quitting. So we could have participant 1 who's interested in quitting, participant 2 who's not interested in quitting, nonetheless goes through cognitive behavior therapy, and then we can compare, the AB design with between those two participants, between participant 1 and participant 2. They might both go through the AB design, and this we could call a small n study, or we could even call it a single subject study, even though it violates the definition of single. That's why it makes more sense to call it a small n study, or sometimes called case study. Again, that doesn't fit the definition of case, which is singular. But anyway, the point is, whether you use one subject or more than one subject, because of the strong internal validity of the treatment reversal design, you're able to test not only one experimental factor at a time, you could test multiple factors at a time and still get good, reliable, or let's say good, high validity evidence of the impact or influence or contribution of these different kinds of variables on your measurements. And you can come up with pretty valid conclusions based on your interpretation of the data that you collect in these single subject treatment reversal design studies. Any thoughts, questions? Okay. Next slide, data analysis. Surprisingly, visual inspection is the main approach for single subject designs and treatment reversal designs. Inferential statistics work well based on larger samples of participants, but are of questionable validity in small sample studies. Some statistics can be used as supplemental analysis besides visual inspection. A common statistical analysis is percentage of non-overlapping data between the treatment condition and the baseline condition. The proportion of treatment observations exceeding baseline condition average. All right, so the baseline, you've got some average, right? Let's say we're measuring cigarette smoking per day, and we come up with an average of 7 cigarettes per day. Then we do the treatment, and we see that the average is 5 cigarettes per day. Now, there's going to be some overlap between the baseline and the treatment conditions. some days in baseline, there will be more cigarettes smoked than, sorry, less cigarettes smoked than in the treatment. And in the treatment, there will be some days in which there are more cigarettes smoked than in the baseline. So even during treatment, someone might smoke 8 cigarettes a day one of those days. So there's going to be some overlap of data points or observations or testing results between condition A and condition B. Despite the overlap, we can see good, strong evidence of an effect of the treatment by looking at the percentage of observations in the treatment that are higher than the percentage of observations that are, sorry, I say above or below. It really depends on the study. So in the case of smoking cessation treatment, if during treatment more than 50%, see, by chance, only 50%, if the treatment did not work, by chance, during the treatment condition, observations should be about 50% higher than the baseline or 50% lower than the baseline. If we observe that the percentage of observations are much different than 50% above or below the baseline, we have evidence of an effect. It's not super clear. It's a bit ambiguous. Like if we say 60% of observations are below baseline, well, 60% is not much different than 50%. If it's 70%, now we're getting somewhere. If it's 80%, oh, okay, we're seeing a pretty strong effect. If it's 90%, yeah, that's really clear. All right, so there's no fine line to say there's a absolute certain effect. There's some cloudiness or ambiguity, but this is always true in our field in psychology, because psychology often, I mean, I can't say it's always true in psychology, but it's often true in psychology that the evidence that we gather is not clear cut and it's not black and white. It's a bit ambiguous. This is why our field, psychological science, is often referred to as a soft science because of the ambiguity in interpreting the results. That's what makes it soft. It's because of issues with reliability. It's because of the possibility of type 1 error and type 2 error and false positive, false negative, and wrong conclusions. That's what makes our field called psychology or psychological science. That's what makes it a soft science. And to the extent that we get away from the softness, which is the potential for wrong conclusions and errors of interpretation and errors of conclusion, as we get away from the errors, then our science becomes more hard science like physics, chemistry, biology. I know I went off on a tangent there, but this has to do with the philosophy of science, which is very important. It's an important underlying um, element of this course. Again, it's an important underlying element in this course that our field is a soft science, and we simply have to accept that and deal with that to the best of our abilities as scientists. So yeah, that's how we make our statistical inferential conclusions when we run and look at the data. So this is our data analysis in the case of single subject studies with reversal designs especially. Elements visually considered are level, trend, and latency. What I'm talking about here are the elements that we visually inspect. And when I say visually inspect, we look at the next slide and we can see what I'm talking about visually inspecting the elements. All right, so we have these three elements. We have level, trend, and latency. Level is another word for condition. If we have one independent variable, there are different levels of the independent variable. There may be only two levels, there may be three levels. It's up to us how we define, how we operationalize the independent variable in our study. If we have a study on temperature, we could operationalize that, our levels as hot and cold using temperature markers like 25 degrees, 30 degrees. Or we could operationalize our level at 20 degrees, 25 degrees, 30 degrees. So the levels are whatever we decide them to be, and they are conditions and they are called levels. Trend. I should have bolded these terms because I like to bold vocabulary words. Anyway, trend is the next one. This is the observable tendency. So it's a tendency. Trend means tendency. It can be a tendency to increase or decrease. I'll show you an example of that. And then there's latency, time from treatment until the effect is observable. When you give a cognitive behavioral therapy session to a smoker, whether, okay, so then we can measure the effect of that therapeutic encounter, and we can measure that and see how immediate was the impact or the effect of that therapy session on smoking, smoking habit or smoking quantity on a daily measure basis. So if we see therapy happens on day 0 and we measure on day 0, day 1, day 2, day 3, we might see on day 0 the smoking goes from, let's say there's 7 cigarettes smoked on day 0. We might say, oh, look, the therapy had 0 effect. It's not different than baseline. The issue here is that there is a certain latency which we are not yet acknowledging. If the latency is like, um, let's call the latency as 3 days. So on day 1, we see six cigarettes smoked. And then day 2, also 6 cigarettes. And then day 3, 5. And then day 4, 5. Day 5, 5. Day 6, day 7, 5, 5, 5. All right. So then we can see that the latency took about 3 days. Takes about 3 days for the full effect of the treatment to be fully observed, you might say. We don't know how long it takes for a treatment to be fully observed, but we can see that the latency is not immediate. We don't see like a immediate and permanent drop in smoking immediately as soon as a treatment session happens. All right. So it takes some time for the treatment to be absorbed or to affect the person. It takes time for treatment to happen. Treatment takes time. And so that's what we mean by latency. Latency can also mean reaction time. So another word for latency is reaction time. All right. Quick explanation about this graph. Well, it's much easier on the next slide because I label these things. So here with the labels, you can see there's panel A on the left, panel B, panel C on the right. Each of these panels is called levels or conditions. The vertical line that separates the panels, that's when treatment occurs. Because treatment occurs between observations, we can say that it's an interrupted time series because the series of measurements is interrupted and time then becomes divided. There's time A, time B, and time C. So you could say it's interrupted time or interrupted conditions over time. Interrupted measurements because the conditions interrupt the repeating measurement or the change in conditions. Anyway, so yeah, those are levels or conditions or panels, different words for the same thing. All right, then there's the vocabulary word latencies. Latency is the reaction time, response time, how long it takes for treatment to be seen or observed or inferred. Now, I circle not just the first dot following treatment, and I circle not only the last dot, I did circle only the last dot before treatment. The point is, we don't want to infer the latency only from a single observation once after treatment occurs, because that single observation might be due to chance. So we want to keep observing over time and make sure that what we think of as a latency really is that we're measuring the latency correctly. So we want to observe once we change the treatment condition, we want to keep observing for a while, and we can infer the latency from repeated observations. So here we can see that the latency is rather immediate. So we can describe latency as immediate or prolonged, or it takes a long time, delayed. Slow is a better word. We can see slow latencies and fast latencies. In this illustration, we have very fast latency because the the drop from the drop in the dependent variable, the measurement drop from panel A to panel B is immediate. It's a very fast, immediate drop. If it's an immediate drop, that's called a very short latency or very immediate latency, fast latency, quick latency. And the other vocabulary word to learn here is trend. You can see in the bottom panels that there's a trend in the baseline already. There's a baseline condition trend of improvement in the dependent variable, or the increase in scores. We might explain that trend as due to practice. The more that you are measured, the more good you get at performing in that measurement. So there's a trend there. Then we can see that the trend, if anything, it's continuing upward but slowing down during the treatment condition. And then level A, when we go back to baseline or no treatment condition, let's say that A is no treatment, then we see that the trend has leveled out. There's no trend. Or if anything, maybe there's a slightly downward trend there. So trend is a way to describe this layout or representation of data. And you can describe it using the words increasing trend, no trend, or decreasing trend. You could also call it improving trend or decaying trend, or some other synonym, reducing trend. All right, so we've got these vocabulary terms: trend, latency, levels. Next slide. It's 1:55. Let's have a 10-minute break and come back at 2:05. Okay?
Okay.
All right, great. See you in 10 minutes. Hello, welcome back. Yes, Nope Nari, you can have a group consultation after this class. I think we could just stay on Zoom. Since you asked first, you get it. All right. Now let's go on with lecture. Can you hear me? Is everything working?
Yeah, everything's working.
Cool, thanks. All right. Sharing screen. Averaging in large N studies wipes out individual differences. So when we read most psychological science articles, they use large N groups. I mean, I think it's fair to say most psychological research uses large N. But single subject studies are hard. It's hard to know why people behave the way they do. It's hard to control extraneous factors. So there's some strengths and weaknesses of both single subject, also called small n, as well as large N studies. The large N studies wipe out individual differences. The small n studies don't. No research method or design is perfect. The strengths of one are the weaknesses of the next. Combining approaches using small n and large N studies combines strengths and cancels out individual weaknesses. What I mean is if you use both approaches, small n and large N, for the same research question, as you could call it study one, study two. If you did that, you would be capturing the strengths of both methods and protecting against the weaknesses of either one. Because the strength of one overcomes the weakness of the other. If you uh, if you judge the results across studies and look for the common observations across studies, common conclusions. One method offers mild certainty, but converging lines of evidence from multiple methods offers much higher certainty. This is the strength of the multi-method approach. Now, I mentioned small n and large n studies. These are just two possible research methods. Anytime you use multiple research methods, you're going to end up with stronger overall project and stronger conclusions, greater certainty. Findings only generalize to the real world when features of the study are similar to features in the real world in terms of the participants. Are your participants like those in the real world? And the second part, the study setting, or the second reason. So the study setting should be very similar to real life. Otherwise, there's a lack of external validity. External validity means validity, or uh, it means that what you find in your experiment is also true in the real world. So if your setting is similar to the real world, then you have better external validity, which means that your results are more likely to be valid in the bigger picture, in the real world. So these are just two broad and general features of studies and what makes them more or less valid, the results more or less externally valid. And the combining or converging evidence is something that strengthens the internal validity. So if we're looking at this slide as 3 bullet points, 1, 2, 3, the second bullet point is about internal validity and the third one is about external validity. Okay, now we come to practice. And then after that, I'll ask you how your group projects are doing. So first, let's do this practice. And so I'm going to give you 15 minutes. I'm going to break you up into breakout groups or rooms. And I want you to answer these 8 steps or these 8 questions. I want you to design your own research, your hypothetical research study to answer the question, the research question, Does regular exercise help relieve depression? Does exercise help relieve depression? So I want you to design simple study, specify the treatment, operationally define the variables, decide when and where the observations will be made, explain how some hypothetical result would answer your question, create a graph that displays such a hypothetical result, describe what the results show, and comment on the level, trend, and latency that you observe in your graph of your hypothetical results. And when I talk about drawing a graph, please use this type of graph right here. In other words, you're designing a hypothetical study using a single subject design, please, using like ABA design or something like that to answer the question of whether regular exercise helps relieve depression. All right, so then I can showcase your group's answers if you want, like your graphs that you draw. But you'd have to email me your materials, then I could share them with the class. I'm not sure if you could attach your results to in the chat box. I don't know if the chat box allows you to attach things or not. But anyway, whether you somehow you get your answers to me by probably by email, then I could visualize them here for you. Well, to let you explain what your group came up with. All right. So give me a moment. Okay. Go to your groups and discuss these 8 points or 8 questions.
Sorry, my Wi-Fi kicked me out.
Oh, let's see. What's your name?
Dain. I
Oh,
th- I was in room 4 or 5, I think.
giving you to,
Yeah, thanks.
sure. Okay, welcome back from your breakout rooms. And can anyone share with me what your group decided? Let's see. Oh, okay, here's a link. So I'm opening this.
Yeah, our group did it on a Google Docs.
Perfect. That's even more convenient than emailing me anything because you can just post the link. All right, so first I'm looking at a link sent to me by Diane Lee. So here, if Diane, if you want to comment on this, on what you've created here.
So basically, we just did a simple single subject study for depression, and we had 10 participants, and we used a ABA reversal design where for A we exercised and for B we did exercise to make sure that exercise was what was affecting depression.
Perfect.
Yeah, and we drew a graph, but it's a very badly drawn one.
That's all right. So your treatment is exercise for 1 hour. And your measurement is mood, asking the participants' mood as well as their behavior. Let's say that we're dealing with which one on the graph, mood or behavior?
For the graph, we just kind of thought of it as sort of like maybe combined, but I guess it fits better for behavior since it's more of a observed sort of thing.
Right. Okay. So depression, we could even say depression scores, which are both a mood and a behavior. All right. Yeah. So observations are done in a quiet room with a questionnaire, and results show that exercise improves mood. And here's your graph. I will see if I can enlarge it.
It was done on a sticky note.
That's great. Okay.
You're like on like crop mode. Like, I don't really know how to explain it.
Okay.
Like,
All right.
I think you should like click undo first
Undo. Thank you.
and click off and then enlarge it.
Thank you.
You're welcome.
I don't know how. Never mind. I think we can see it. Small. All right. So obviously, all right, what else? Let me read what you wrote here.
I can read it if like it's too.
It says when participants exercise, they got better scores and level people who exercise do better than people who don't. The trend, so yeah, that's what the level says. The trend says decrease low mood, decreased anxiety, yeah. And the latency before starting exercise versus after exercise. Well, the latency, you can say that the latency is very immediate and very short because the change from here to here is very fast. So we call that a short latency or a fast latency. Okay, great job. Now let me take a look at someone else turned in a Google Sheet. And by the way, someone commented on your graph that it's an amazing graph. So there you go. Compliments. All right. Next one is this. Yeah. Okay. Who did this one?
This is group 3. We didn't have time.
Yeah, we have no idea to create the graph.
Yeah.
Okay.
Figured out how to make it, but we couldn't. I think we should have just took a picture like what Diane.
Yeah, what Diane do.
The
Sounds
graph.
good.
Big brain.
That works.
Yeah.
All right.
that
So
works.
what can you tell me about this study?
So for our study, we were trying to, of course, all of us are doing the same thing. The effects exercise has on levels of depression. We were doing cardio exercising, starts from 7 a.m. till 9 a.m. I forgot to write like running and jogging. And the afternoon muscle exercise will be done from 1 p.m. till 4 p.m. And this will happen 6 days a week. And on the last day, which is Sunday, we will also we'll have them come in to do questionnaires, and we put the Pacific questionnaire, the Center for Epidemiological Study Depression Scale. And I forgot to say we're also doing this in a controlled dormitory so that we can we'll get, of course we're gonna get them privacy in their rooms, but we also have to control where they're going, and they'll tell us where they're going and stuff like that, so we can track where they are, again under consent, of course. So for 6 days a week they'll be exercising. On the 7th day we'll check up on them, see if they're feeling better or they're feeling worse, and the duration will be 5 months.
Great.
Our hypothetical result is after 1 month of exercise, the participants have a lower depression score from self-report, and we expect that to continue and remain stagnant to a point. But
A
we can't really
graph.
show the graph because I don't know how to edit what's on the graph.
A graph has spontaneously appeared here on my screen. All
It's
right.
not finished. We don't know how to
It's
change
just
the
the
variable.
beginning template.
Yeah,
Yeah.
I don't know how to change it.
Good.
Yeah,
I like
we
it.
haven't changed it.
Just say for the results, let's pretend that there are results. We'll say that for a while the depression scale lowered until it kind of stagnated and didn't change. And when the fifth month ended, the duration was over. There was an overall lowering of depression rate,
Yeah.
but it only lowers to a point.
It looks good. Makes sense. All right. So
Yeah.
we could think of baseline as the beginning of the line graph. And then we've got your exercise treatment, call that week 1. And then we've got week 2, week 3, and then it goes on for 5 months. Excellent. Looks good. And you've got 2 lines for the 2 people because you've done a
Yeah,
2-person study. You could do that. You could say that.
So the trend is the gradual decrease in depression. Latency, the time is from 4 months. The level is from 1 month, from the first month to the second month, there was a big decrease. From the second month to the third month, there was a smaller decrease. And from the third to fourth month, it stagnated and did not change. Again, this is what we would have made if we could control this graph.
Right. These are the predictions you would have made. Great.
Yes.
Good. Yeah, very good. Nice job. Okay. Let's see. Okay. All right. Oops. Oh, sorry, I forgot about the third group. Does the third group want to talk about what you did?
Well, we could talk, but we don't have anything to show for it.
Okay, please tell us.
Okay, so for us, we did for the treatment, we decided to go with a gratitude journal, space once a week, go on for 9 weeks, and separate into 3 sections, with the middle section being a removal design where the treatment will be removed to see the effect and to separate the actual effect of the treatment. The effect on treatment will be tested via Beck's depression inventory, and total score will indicate whether or not the treatment actually worked on a week by week basis. The level should show a gradual increase in the first section through the 3 weeks and then show a drop. A significant drop would be preferable. The speaking from the study perspective, and then gradual increase again on the last section.
Excellent. Yes, you've got the right idea. All right, thank you. Do you want to comment on level, trend, and what was the last one?
The latency.
Yeah.
So since we separate into 3 weeks, 3 sections with 3 weeks each, the first week would be a gradual increase for the level from point by point for the whole 3 weeks, and then a drop on the 4th week, which would be the second section where the treatment is removed.
Mm-hmm.
That would show a gradual or a significant drop as a trend, and then an increased trend again on the 3rd section. So the latency would be, I guess, for the nine whole weeks would be the latency would be the increase on the first section, decrease on the second section, and increase again on the third and last section.
Say that the latency would be fast or slow.
Slow.
Slow. Okay, great. This is good. It means it takes time for the treatment to take effect, but once it takes effect, it can still be a very strong treatment.
Yes.
Good.
Hopefully.
Yeah, excellent. Great. You got it. All right, next, let's move on to ask you how your group projects are going. Thanks for contributing and participating in that last exercise. If any aspect of participation seems uncomfortable or unquestionable. Oh, I see. Thanks for contributing and participating to one another's research. If any research project feels uncomfortable or questionable to you, please report it to me. I don't want groups, questionnaires, or data collection making students feel uncomfortable. So you can report it to me because I'm acting as the institutional review board for our class's research activities, and I urge you to keep participation as anonymous as possible. We don't need to know which data comes from which student. Please formulate your procedures with anonymity in mind. Concerns about materials preparation and data collection, if you have any, please email me. CC your group members if you want, or at least keep them in the loop after you've communicated with me. And that's it. So that's the end of class. Do you have any questions or concerns or comments?
For my group, we collected our data yesterday.
Yep.
So do you want us to like tell us the result, or do we just do that on our own?
You do that on your own.
Okay.
Great. I haven't taught you how to do that yet.
Yeah.
So you can wait on that. Or if you want, you can analyze it however you think you're supposed to analyze it.
I think we
that
should
to
wait
you.
on that. We'll wait on that since it's not due yet.
Yeah, you can wait
My
on that.
question before Diane, I was wondering, are we going to have a quiz? Do we have like a reading assignment for this week?
Great question. I meant to say something about that. I have waived the reading assignment last week and yesterday, and I want to waive the reading today as well, so you don't have a reading assignment this week.
Thank you so much.
You're welcome. And there's no quiz next week. And I was even thinking about just doing away with quizzes altogether. Now, I've already given you a couple of quizzes in this class.
I think 3.
So, well, I'm considering doing away with quizzes. But to do that, I would need to increase the grading weight of something else. And I'm thinking to increase the grading weight of your research paper So how does that sound to you guys? I mean, I don't really need your opinion. I can just make a kind of top-down decision, but how do you feel about that? I know there's only 10 of you in the class right now.
Fine with both. And I mean, we are going to spend a lot of time on our research paper. So if it has a bit more weight, then I wouldn't mind. Right?
Right? Thank you. Anyone else?
I agree with that.
Okay, thank you. Anyone else? Dissenting opinions? Okay, well, let's just, okay. No more quizzes for this course. There it is. That's the decision. No more quizzes for the course. The 2 quizzes I think we've taken, 2 or 3, I don't remember, will still count. And I'm going to increase the weight of your research paper to fill in for the remaining missing, the quizzes that I'm not going to give. All right, so that's decided. Cool. All right. We're not doing quizzes anymore. What else? Other comments, questions? I have already gone through about half of the research first draft introduction sections and given comments on that. I still need to get through the other half, so I'm going to work on that today. Anything else? Okay. How about, does anyone have your materials already ready and prepared to collect data today? If you did, you could send that by line or email to the class. If I have already approved your materials. I think a lot of people are postponing and delaying until the 30th, and we might have to have even later data collection dates, possibly. All right. Anything else? If not, good luck continuing to prepare your experimental materials. Get on that. You should be ready to collect data by next week, ideally. So everyone needs to get on that. All right. Okay, best wishes, and that's the end of class for today. Thanks for coming. Bye.
Thank you.
Thank you.